Today on BRStv, we're going to geek out on Apex with a full ULM code, and then of course, give away one at the end. I'm Ryan, your host of BRStv Tank Trials ULM Edition. This is episode 18 of ULM and development of an ultra-low maintenance system. The goal is a stable, show-caliber reef tank which requires as little maintenance as possible, potentially performing only a few minutes of maintenance a month. Today we're going to walk through the goals that we have for programming every single piece of equipment on the Softy tank and then show you how we achieve them using the Apex controller. The single Apex is actually running all three tanks, so we'll also highlight some subtle differences in programming with the other tank styles. The Apex is really capable of an incredible amount of redundancy and notifications on how well our life support system is running. It's pretty obvious why a controller can not only reduce some elements of maintenance, but also make sure that everything is operating properly and allow you to be away from the tank with near complete certainty. If anything ever goes wrong, a backup solution has already been implemented, or at least you know about it immediately. Fairly recently, this has gotten a lot easier to do and really accessible to anyone who has a desire. The most obvious advancement is the focus on task-based configuration and control of actual equipment, like a skimmer, heater, or return pump, designed to meet specific objectives rather than just controlling an outlet that these things happen to be plugged into. Well, it really is just a change in mindset. The approach is recognition that we're attempting to control a heater here and knowing that there are some pretty simple prompts that anyone can use to successfully set up a heater and meet best practices for a successful reef tank. For that reason, while there are a variety of ways to program in Apex, we're going to focus on using goal-based tasks as a primary method. I'll also note that I'm not going to cover the various setup steps like calibrating probes because that's so straightforward and easy. This does assume that you have done a handful of setup steps. We're going to start off with configuring our primary heater. Fair warning, this first piece of equipment will take a bit longer to explain because it's the first one, but after that it gets rapidly easier. Our goal with the primary heater is simply to maintain a stable temperature in the tank around 78 degrees. However, controller allows you to do much more than that. We also want to be sent alarms if the primary heater fails catastrophically in either the on or off position, meaning if it gets stuck on, stuck off, internal thermostat becomes inaccurate over time, or it simply breaks altogether. One of these instances is pretty likely to happen inside of a couple-year window. In addition to that, we'd also like to turn the heaters off automatically when we perform general maintenance or when the return pumps have been intentionally turned off. This will prevent them from getting exposed to air and burning out or melting in an acrylic sump. Also eliminates issues where your heater and temp probe are in different areas of the tank and can prevent overheating a portion of the sump when the heater's internal thermostat isn't operating properly. So that's a lot to achieve, and it might seem like it would be complex to implement for something as simple as a heater, but it can be done in a couple minutes with a few straightforward tasks. First, we're going to hit the tank link up top, and under configuration, select tasks, and then heater from the available options. Select the outlet you plugged your heater into, hit next, and then name it something. In our case, with the Softy tank, we named it soft_HTR1. Hit next and select your Apex temperature probe. Most of you will only have one, but we have a whole bunch of modules on our tank in Apex. In this case, I'm going to select the one that's labeled SOF-TMP. Enter 78 as a minimum and 78.1 as the maximum. Now I set my heater's internal thermostat slightly above that range, and the Apex will control the tanks accurately with the heater and Apex thermostats backing each other up. Next, I want those alarms if the heater or controls fail in some manner, or even if human error just causes the heater to get stuck on or off. Doing it at the temp probe is as easy as selecting the probe alarm from the tasks, selecting your temp probe and naming it. Again, in this case, we named it SOF-TMP and selected a range where you want to set the alarm. In our case, I want to know if it's fallen a couple tenths of a degree below where it should be, so a low is 77.6, and I'll let it rise a full degree above normal before it sets off an alarm and notifies me, so a maximum of 79.2 degrees. Hit send and the alarm is set up. I would note that some people will allow the tank to rise or fall more than that before the alarm goes off, but we're attempting to keep this tank as stable as possible and want rapid notification when something fails and willing to put in the effort to create a system capable of that stability. As a final failsafe, I'm going to use a quick task to set up the power monitoring alarms, which means that Apex is monitoring the heater's power usage for abnormal behavior. Both too high as well as too low or none at all, the Apex will set off an alarm and notify me in the event that the heater is performing erratically. Most importantly, when it isn't consuming any power but should be. This is really the best way to be almost instantaneously notified of equipment failure on most of the individual pieces of gear. So in that spirit, we're going to hit the power usage alarm task to let the outlet that the heater is plugged into, which in this case we've named soft_heater1. It'll give some suggestion based on prior usage, or we can manually select something. In this case, it's a 300 watt heater, so I'm going to select 250 watts as my minimum and 350 watts as my maximum. Next, and send. If you're not actually sure how much your heater actually draws, you can always check out your power draw graphs by clicking the chart. The soft HGR1W outlet, the W stands for watts, and you can see the actual power usage for the outlet for the last week at a quick glance. In this case, our heater draws around 270 to 280 watts. Now the last part of heater setup is related to making maintenance a bit easier and safer, which is turning the heater off during standard maintenance. Most reefers use one of the 4 feed modes to automatically turn off a bunch of equipment during standard maintenance, and then automatically turn it back on after a short period of time so you don't forget or have to deal with the hassle. This can be done one of 2 ways. The most obvious is just adding the heaters to a feed mode. However, as an alternative, if there's other pieces of equipment that will likely be on your feed mode or maintenance mode, you can actually tie it to that piece of equipment as well. I'll show you both ways. This would be easier if there was a task for feed or maintenance modes, which I'm sure they're working on, but the current easiest way to add a feed mode is to open up your outlet by clicking on the configuration gear and adding a simple command line to the heater's programming. What we're about to do is admittedly a bit reef geeky and next level. You certainly don't have to implement all of these more advanced elements to get the other functions, but I think it's valuable to show some of what the Apex is capable of doing when you want to take it to that next level. By making the advanced code available, really anything is possible. So to add the feed or maintenance mode to the heater, just find your primary heater outlet, hit the configuration gear, and then select Control Type Advanced. This will show you the actual commands that are operating the heater behind the scenes. We're just going to manually add a command line to the end. Of the 4 available feed modes, I'm going to use feed mode A for the softy tank, so all we need is a command line that says, if feed A 000, then off, then hit send, and you're done. Now, anytime I hit that feed mode A button in Apex Fusion, the heaters will turn off with the rest of my desired equipment like return pumps and power heads for easy to perform ULM maintenance. So adding that simple line was pretty easy, but we're going to take a slightly more advanced approach. Basically, it's not just when I trigger the feed-based maintenance mode that I personally want the heater off. It's really anytime the return pumps are intentionally not circulating water through the sump. So rather than add that line about feed mode, I'm going to add a command that says, if output soft LFT RTN off, then off. Soft LFT RTN is my left return pump, so this means that anytime the return pump is turned off, it will also turn off my heaters. Not just during maintenance mode, but anytime the return pumps are not powered. You probably named your return pump outlet something different, so just swap out that part. Since we're running redundant dual return pumps on our ULM tanks, I'm going to add if output soft RGT RTN equals off, then off for the right return pump as well. So now if either pumps are intentionally turned off, the heaters will be turned off as well, avoiding a wide variety of fairly common issues. So obviously all this isn't as easy as just plugging a heater into the wall and calling it a day, but with 2 to 3 minutes of our time, all of our ULM goals for the heater have been nailed. We have a tight, accurate temperature window. We'll be notified almost immediately the moment the heater fails in almost any way, and maintenance will not only be easier, it will also be safer, because powered heaters will never be exposed to air if we drain the sump, which is a fairly common place to perform water changes. Because of that, the heaters won't burn out, melt power cords, or the acrylic sump, and I don't have to worry about turning them off, and more importantly, back on again. It's all done automatically. The tiny bit of effort up front won't just save me time later, but also helps me sleep at night knowing the tank is protected, particularly when I'm away from these office tanks at night, on weekends, and when I'm on vacation. Okay, so setting up a heater and alarms was pretty straightforward, but whenever possible, I'd rather the Apex actually solve the problem for me rather than just notify me of it. The Apex automatically implementing a solution for the issue is obviously invaluable when I can't be there to fix it at that exact moment. So in that spirit, we're going to set up a redundant heater which will only be triggered when the first one fails, meaning we'll set it to about a half a degree lower than the primary heater. In this case, it'll be used in the event that that first heater completely fails. I also want an alarm when it fails, as well as the same maintenance code. Now if you wanted to, you could walk through all the same tasks and set up the secondary heater. However, there's a much simpler way to do this, which is just copying the programming from the first heater. Click on the configuration gear of the outlet that controls the secondary backup heater. Then in the upper right, there's a copy icon that looks like 2 pages on top of each other. Click it and select Soft HDR1 and OK to copy that programming over. Now if you wanted both heaters to turn on and off together and back each other up that way, you could just hit send and be done with it. In our case, I'm operating this one as a true backup, which will only be triggered in the event of a catastrophic failure of the primary heater for a couple of different reasons. One, I only have a 20 amp wall outlet to run all 3 tanks, so I don't want 6 300 watt heaters turning on and off with a potential total of 1800 total watts. But running only one, we cut that down to half and a maximum of 900 watts at any point. By running as a true backup, that also means the backup has very few operational hours on it and very few on and off power cycles, which means that it should be more likely to be functional when you need it to operate. So that means I'm just going to change the minimum temp to 77.5 and maximum to 77.6 and leave the rest of the command lines alone. Hit send. I do want to know if the secondary backup heater fails, so I will take a moment to walk through that power usage alarm task, which will tell me if the backup heater isn't drawing any power when it should be. Moving on to something pretty similar with cooling the tank in the event that it needs it. This is pretty important around the office here because everyone is always messing with the thermostat, and occasionally the air conditioning simply breaks or is inadvertently turned off. In which case, I need a fan to be activated to promote evaporative cooling and prevent the tank from overheating. I think we've all read articles on the negative effect of rising ocean temperatures on coral reefs. None of us want that in our homes, particularly with some of the more fragile SPS species. Same simple setup, click on tasks and then chiller. A chiller can be anything designed to chill the tank, a complete chiller, a fan, or something like an ice probe. In this case, we'll select the outlet controlling the fan, name it soft_fan, our desired temp probe, my on and off, which will be to turn the fan on when it hits a maximum of 78.5 and off when it drops below 78.4. Hit send and you're done. You can also set up power monitoring on the fan that will let you know if it failed, but most fans use very little power, so it might be hard to dial in. We're using the Tunes Aquawind just because it's one of the only options which look decent on the tank. It does draw 3 watts, so I'm going to set the power monitoring to be triggered under 1 watt. Before we move on from temperature-related topics, we're also going to set up monitoring alarms for the ambient room temperature of the room the tanks are in. If you have an extra temp port on one of the modules, it's cheap, and I'd strongly suggest using it for this. I say that because it's super common for members of the household or office to make those adjustments to the thermostat, intentionally or inadvertently turn it off, or have your furnace or air conditioning fail altogether. All of which can cause a room to get very cold or hot fairly fast. For a few bucks, we can send an alarm anytime that happens so we can do something about it before it affects the tank. Again, I think particularly valuable for ULM tanks where you may spend significant amounts of time away from the tank. All you need to do is mount the temp probe on the wall, click the task, probe alarm, select the ambient room temp probe, and follow the prompts that we've already done for the other tank temp probes. This is probably a 30-second process. Moving on to my first return pump, again for the ULM here, I'm running dual return. So if one fails or gets clogged, I have another running and keeping the life support operating properly. In this case, I just want the control to keep the pump powered most of the time, let me know the moment that it fails, and turn off during maintenance mode. In this case, it's just a 2-step process to achieve all that. First hit task, return pump, and name your pump. In this case, they know that most people are going to want their return pump off during a maintenance or feed mode. So select feed mode A. The delay field means extra minutes for the pump to stay off after the maintenance or feed mode has been completed, which in this case, I want to be 0. I want it to come back on immediately with all the other equipment when the feed mode is done. Hit next and send. It is pretty nice that in this case, we didn't have to touch the advanced code to get the feed mode applied because they added it in with one of the task steps. The return pump is absolutely something that everyone will want to turn the power monitoring on for, so I'd run through that task as well. One thing to note is as the pumps clog and performance deteriorates, that often means that they'll consume less power than normal, meaning that the power monitor here might not only tell you when a pump has failed, but also when it needs to be maintenance to improve performance and promote the longevity of the pump. Again, knowing when to perform maintenance with real data, this is ULM all the way. The second return pump we have running isn't a backup per se, but more a redundant pump that operates identically to the primary pump. For that reason, the programming can be done with that easy copy outlet function again, followed by the power monitoring task for this pump as well. Once that's done, not only do we have redundant return pumps, but notification if either fails, and potentially even notification that they need maintenance, a solid ULM application of return pumps. Now looking at the right and left power head, which will be programmed the same, really my needs for the power heads are nearly identical to the return pump. I want them powered most of the time, turn off for maintenance, and tell me when they've failed, and ideally when they require maintenance. So not surprisingly, the code is the same as the return pumps, meaning that we can use that handy copy feature followed by the power monitoring alarms tasks as well. I would note that while the power monitoring will catch complete failures, DC power heads often range from very low power consumption to higher rates, and it's more difficult to trigger an alarm based on just decreased output or when they need maintenance. However, you can check the power graph for maximum peaks from time to time. I've done this with other pumps like the Gyre. I guess I'm not sure how well this will work on a magnetically coupled pump like the Vortex. Anyways, with a quick outlet configuration, copy, and power alarm task, all of our power heads needs have been achieved. Looking at lighting, there are two aspects: how we use the Apex to control the on-off function of Kessel lighting and the ramping of color and intensity. You could just run the light off the wall or standard power strip and use the variable voltage ports to control it. However, if you have an extra AC outlet on the Apex, plugging the Kessel into the controlled outlet adds redundancy and allows you to use power monitoring. Knowing the lights are actually working when I'm away is an important component of a ULM, so as long as you have a spare outlet, I would do it that way. Since I have those extra outlets available, I'm going to do it separately with the goals of turning the light on and off at designated times, turning the light off if the tank temperature ever exceeds something fairly high, like 81 degrees. I also want to stay off for 30 minutes in that event rather than flicker on and off at 80.9 and 81 degrees. And lastly, of course, I want it to let me know if the light fails entirely. Again, there's a task for lighting that I'll use for most of that, so select the light task, select the outlet and name it, and then select your on and off times. In our case, it'll be a 10-hour cycle at 8 a.m., off at 6 p.m., or 1800 hours. Enter 30 minutes as the minimum off time, and then select the tank's temp probe and 81 degrees as the cutoff. After that, the power alarm task, and I'm done. In this case, I'm just going to set the power alarm at something pretty low, like 7 watts, because these lights will be ramping up and down throughout the day. But overall, this is a pretty easy lighting setup. The Kessel light that we're using allows you to use the Apex's variable voltage ports to control the color and intensity of the light, something that we're going to use. There are no real ULM goals for this, but I will show you how it's done. First, you'll need a cord like this. It looks like a headphone jack on one side and a phone jack on the other. Go ahead and plug those in, unlock your dash, find the 2 variable voltage ports, and then drag them down. Click the configuration gear to open the outlet, name it, and hit send. Then locate our friend, the magic wand, which is going to make this about as easy as possible. There'll be a bunch of data points that you can just drag around. For intensity, I'm going to set 6 points starting at 7 a.m. 0%, 8 a.m. 20%, 9 a.m. 100%, 5 p.m. 100%, 6 p.m. 20%, and 7 p.m. 0%, which will couple with our 10-hour lighting period. I have our effective photo period starting at 20%, so there's enough power for the power monitoring to work properly. For color, I personally don't need it to change color throughout the day, so I'm going to use a wizard to set 2 points of 30% on both ends of the day. Let's go ahead and set up one of the best ULM aspects of the Softy tank, the automatic water change. Goal here is to never pick up another bucket of salt water or mess around with siphons ever again. Again, we have water storage a few rooms away, routed tubing through the ceiling, and using the Neptune dose to perform these automatic water changes. Setup, not surprisingly, is a simple task again. Hit the dose automatic water change task. Take particular note of which way the image shows you the head spin and how the tube should be oriented, because the dose heads are capable of spinning both directions. Click next, and the dose you're using for this. Then name each pump head, probably something that indicates clean and dirty, the periods of time that you want the pump to perform the daily water change. It does make a small amount of noise, so you may want to schedule it to be done at night. In our case, the pump is in the other room, so I'll spread it out over the entire day. I want to change out 3% a day in these 60-gallon tanks, which is fairly aggressive, so I'll enter 6,800 milliliters in the volume, hit send, and I'm done configuring my auto water change. Done with siphons, done with hauling buckets around the house. And I got one quick additional note for anyone with wood floors. This type of auto water change system, in removing the need to manually add and remove water from the tank, will go a long way to saving thousands of dollars on floor repairs related to inevitably spilling on them, and a solid choice from day one. I wish I had done this with every tank I've ever set up in my house. It would have saved me a fortune. Related to water changes, I have a container of fresh salt water in the other room that we're using for the auto water changes. I just want to know if the saltwater container is empty and when it needs to be filled, as well as if the float valve failed, in which case it should shut off a solenoid feeding the container. I also want an alarm if it overfills. We're going to use the FFM module, a couple of Apex optical sensors, and their solenoid to do this. For the two alarms of empty and full, these are custom advanced uses of a generic water sensor that can be used for just about anything. So both alarms are going to require some custom commands rather than just tasks. Again, this type of advanced operation is for the 1% of users out there, but it's nice that they're possible. To do this, locate the outlet labeled email alarms and hit the configuration gear. We're going to add a couple of different command lines to tell the Apex to send us an alarm. It's called email alarm, but it'll basically send any type of alarm you have set up in the Apex configuration. In this case, I'm just going to write if WTR low, open then on. WTR low is the low water sensor in my saltwater mixing tank. Open means the sensor isn't detecting water. So saying if WTR low, open then on means the low sensor doesn't detect any water, then turn the alarm on and send me a notification. Pretty similar to that, we'll also add WTR HGI close then on, meaning if the high level water sensor detects water, then send me a notification that the float has failed and the tank is overfilling. Again, I actually want the Apex to do something about the overfill and prevent it from flooding my floor, not just tell me about it. We're going to tell the Apex to close a solenoid if the optical sensor ever detects water above the float valve. So find the solenoid outlet in Fusion, name it something intuitive, in this case WTR RES fill, and I'm going to put in 3 command lines. Fail back off, meaning if it ever loses connection with the Apex, the power to the solenoid should be shut off and closed. Set on, meaning that the solenoid is powered on by default and open. Then if WTR HGH close, then off, which will shut off power to the solenoid and close it. I know some of these commands are kind of Reef geeky, but once you see a few of them, you can see how most of them are pretty easy. If you have some specific advanced needs like these, but don't want to bother learning advanced commands, then you can always post your desires on the Apex community forum, and someone there will normally give you the exact command lines for your goal in just a matter of minutes. Next up, we're going to set up the ATK auto top up. This is available for use on its own, but you can connect it to your Apex for additional functionality. In this case, I want to replace the evaporated water and alert me if something fails. Luckily, the task function makes this super easy. Select ATK from your task function, your module, follow the physical instructions, name the module, select the 2 high and low sensors, check I want failure notification alarms, and send and done. Really anything with these tasks are awesome, just super easy. Moving on to leak detection, the Neptune ATK Auto Top Off has 2 ports for additional sensors that we can use for leak detection, so we're certainly going to use them. I want to be notified the moment any leak has been detected on the tank. So in the task menu, select your ATK leak detection, your ATK module, the sensor that you want to use, check send alarm, next, and send. If you have more than one, repeat that for the second leak sensor. Somewhere between here and 10 years from now, this is almost certainly going to save you from cleaning up a mess, damaging your stand, potentially floors, and even better, the lives of everyone living in the tank. This is a ULM where I'm not here on weekends, so we have the Neptune AFS auto feeders in the tank as well. Right now I only need it to feed once a day or be triggered to feed manually. This is another setup which is almost effortless. Find the feeder outlet in Fusion, name it something appropriate for the tank, and then there's some configuration fields off to the side. In this case, I want to feed at 9 a.m. I only want 1 feeder rotation. I only want it to feed once a day, and I want feed mode D to be the manual feed mode for all the tanks. So if I want to feed them a bit more on command, I can just hit the single feed mode D button for a rotation. Moving on to the skimmer, we want the skimmer on most of the time. However, we do want it off during maintenance mode or really anytime the return pumps are off and the water level is higher in the sump, which can cause the skimmer to overflow. I'd also like to know if the skimmer pump has failed entirely. This is a pretty common piece of equipment, so not surprisingly, there's a task set up for all this. So select your task and your skimmer outlet, name the skimmer, and then select your return pump. Then how many minutes you want the skimmer off after feed mode. There are 2 reasons why you may want your skimmer to stay off for a couple extra minutes. Most people will set it to a few to 5 minutes so the return pumps can normalize the water level in the sump before it turns your skimmer back on. If you are using it as a true feed mode and feeding small particulate or liquid feed additives, you may want to select it an hour longer to allow the food to circulate in the tank. I'm going to set it to 3 minutes, hit send, and we're done. Now, anytime the left return pump is intentionally turned off, the skimmer will be shut off as well. That means feed modes, maintenance modes, or just manually turning the return pump off as well. If you wanted, you could go to that outlet and add a second command line for the right return pump as well, but it's probably not necessary in most cases. I also have a pump that I use for cleaning the system. It's one of the Neptune Apex pumps and works really awesome as a handheld tool for cleaning all the tanks and stirring up the detritus. These feed pumps can be used for a lot of different things, but this is one of those oddball uses that I find to be really useful and certainly better than endlessly squeezing a turkey baster that I was using before. With a piece of silicone tubing, you can even do it without getting your arm wet. I'd call this a great ULM tool. I wish I had some cool way to program it. I'm actually just leaving it on and using a 1-link extension cable to give me extra reach, and then just unplugging it from the extension when I'm done. Alternatively, I think you could use Fusion to turn it on and off as well. I am using the salinity or conductivity probe, so I want to set up the alarm for this as well. I'm going to say that I find them to be kind of finicky, so I don't actually control any of the equipment based on the salinity, but I do want to be notified if it's way off. This is task, probe alarm, select your conductivity probe, name it, your minimum and maximum range. I'm going to set mine pretty wide at 30 and 40, just because I want to know when it's way off with minimal false alerts. Hit send, and now we get notifications anytime salinity is way off. So that's basically everything on the Softy tank. There's only a handful of differences between the 3 tanks. Mainly the SPS tank has some upgrades. An external skimmer fed with a PMUP. There's a Fuge, a UV sterilizer, T5 lights, and Kalkwasser reactor. So I'll give a quick overview of the additional approaches here. The refugium and T5 lighting are just the lighting task, so I'm not going to bother you with that one, but I will note one handy command line. I'm going to put the Fuge light on feed mode B that I'm using for the SPS tank. So for a short period of time during maintenance, it turns that refugium light on simply so I can see under the tank. So again, just clicking the configuration gear for the Fuge light, control type advanced, and if feed B 000, then on. With the skimmer, I'll run the same skimmer task, but once I'm done, I'll set up a command to turn it off if you ever detect a leak. I'd also note that because we're using the Tunes oscillator on this tank, we installed an FMM module for the 2 leak detection ports. I think we may ultimately use another of the 2 ports for an optical sensor to detect high-level waters in the sump to shut down the skimmer, or even maybe the skimmer cup to notify me when it's full. To turn off the skimmer with the leak sensor, hit the configuration gear on the skimmer outlet and then add a simple command line of if name of your leak sensor closed, then off. Then send. Now anytime it detects a leak, the feed of water to the skimmer will be turned off. You can also use the power monitoring task to be notified if the skimmer pump fails. I will say one of the nice things about using these PMUP pumps for the skimmer and reactors is they're using one of the auxiliary ports on the side of the Apex energy bars, meaning that you're not wasting controllable outlets on simple feed pumps. For the UV sterilizer, I would use the always on task, but you could use a lighting task to just set it to 24 hours a day, but then have the advantage of turning it off automatically if the tank is overheating. I'd also set up that power monitoring. However, in this case, I'm also going to use that last sensor port on the FMM for a flow meter feeding the UV sterilizer. Outside of buying the right size sterilizer to begin with, the single biggest performance factor with UV sterilizers is the right flow rate. I'd say 90% of users are just guessing, which is going to produce less than ideal results. Not surprisingly, there's a flow sensor task. You just follow the same simple task to set it up as well. Lastly is the Kalkwasser reactor. In this case, we're going to use the dose to dose 650 milliliters a day through the calc reactor. As a safety measure, I want to turn the dose off if the pH ever gets too high. I also want to monitor the pH of the solution inside the reactor for potency. Setting up a dose is again easiest with a task. Note the rotation of the pumps in the image, select the dose that you want to use, which of the 2 pump heads you want, name it, and the time of day you want to dose. For instance, some reefers only want to dose at night to fight the pH swings or simply because the pump noise is only at night when they're not in the room. In our case, I'm going to let it dose all day to make chemistry changes as slow as possible. We're currently dosing 650 milliliters of calc to maintain stable calcium and alkalinity level in the tank. Send, and you're done. If you want the pH control activated, click on the dose outlet configuration gear, then the configuration gear in the upper right, advanced tab, then enter if your pH probe's name greater than 8.4, then off. Now we won't dose any kalkwasser to the tank if the pH is already too high and above 8.4. In relation to using pH to measure the potency inside the kalkwasser reactor, I'm not going to put an alarm on the pH of the kalkwasser solution in the reactor, but rather just pull down the graph and monitor the changes. pH is really a poor measurement of kalkwasser potency because a few tenths of a degree lower could indicate half saturation, but it's better than zero insight, and combined with testing could give you a better idea of when to clean out and add fresh kalk to the reactor. Well, for all of you that stayed with me all the way through this, I think you can certainly see why a controller like the Apex is light years past just plugging some gear into some timers or a wall outlet. But even more importantly, how it can either automate functions, alert you of failures, power down failing equipment, and even power up backup solutions, which is all really valuable to those of you that are attempting to set up an ultra-low maintenance tank. A few hours of setup now will allow you to sleep at night, particularly when you're away from the tank. If you want a chance at a free Apex this week, hit that lower link in the left corner or head on over to the site, click specials and deals, and then free stuff to win. If you like what we're doing here, hit that subscribe button and that notification bell to be instantly notified when we're releasing new videos every week. See you next week with episode 19 of Tank Trials, Testing on a ULM.